Let's take a look at how to use Microsoft Excel to do a binomial distribution problem. So the first thing we'll look at is you have to define your variables, and we'll see the formula for binomial distribution includes an x, an n, a p, and then true or false. Well, x is the number of successes you are looking for, n is the sample size or number of trials that you're conducting, and p is the probability of success on any random given trial. So in this example, we're going to flip a coin 20 times. We're going to define success as getting heads on a coin, and we know, because it's a classical probability, that the probability of getting heads is 50% on any given flip. So 20 is going to represent our n, or sample size. Our probability of x is going to be 50%, and then x is what we'll be looking for. So we'll jump down here, and what's our probability of getting exactly 10 heads if we flip a coin 20 times? Well, we're going to plug it into the formula here. So 10 is the x value we're looking for. 20 is the number of trials, or n, or the sample size. 0.5 is the probability of getting heads on any particular flip. And we're going to put false in here because we do not want a cumulative probability. Cumulative would give us everything 10 and below. In other words, it would give us x is equal to 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. But we just want exactly equal to 10, so we put false. That gives us an answer of actually 17.6% probability that if you flipped a coin 20 times, you would get heads exactly 10 times. Now, what if we wanted to know what's the probability of getting heads 15 or fewer times? Well, we simply plug that into the formula. 15 or fewer, so we put 15 for the x value. 20 is still the number of trials. 0.5 is still the probability of getting heads on any given trial. Only we change it to true because we want a cumulative probability. In other words, we want to know the probability of getting 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. And that's what it gives us, and that probability is 99.4%. Now, if we don't want to include the value from this example in C, we want to know what's the probability of getting heads fewer than 12 times. Now, notice it's fewer than 12, so when we plug it into the formula, we can't use 12. If we put 12 in here, it would give us 12, 11, 10, 9, 8, and so on, but we only want less than 12, so we put in 11, and we set it to true, and that's going to give us the value of 11 and all the way down to 0, not including 12. Now, if we want to do greater than, the binomial distribution always gives you either equal to or less than. It never gives you greater than. So in order to do that, you have to put in what you're looking for and then subtract it from 1. So if we want greater than 1, we're going to put 1 in the formula. We still have 20.5 and true. That's going to give us the value that is 1 or less, but we want greater than 1. So in other words, we want every value except for 1. So simply subtract it from 1, and that's going to give us our overall probability of 99.99%. These are all the possible situations that you might run into, and this is how you do it.